Good evening, everyone. My name is Rajat Panik. I am one of the primary research scholar at IIT Dharmat, and I am also a teaching assistant or TA of this foundation engineering course, which is conducted by Professor Dilip Kumar Bharat sir in the INPTL, and I am one of his TA in this course. And I have also 6 months teaching experience in NPTL as a TA, and the previous subject was ground improvement, which also conducted by Professor Dilip Kumar Vaidya sir. And today is the week 6 of this foundation engineering class uh, session, and in this session, I will try to first try to uh, teach you the lectures or try to discuss the lectures, whatever in the week 6 plan, and then after that we will try to solve the previous year assignment problem, which will be benefited to everyone for solving the assignment problems in this year. And after that, if you have any doubts, you can tell me at the last of our session. So, one or two points I want to add that this session is recorded and it will be shared to everyone through my YouTube channel by NPTL. And whatever I am discussing here, the lectures and material, I will share to my Google Drive with everyone. So, and one more thing that if there is a technical issue, if happen, then you will not hesitate. Stay on the line. I will join again to resolve this technical problem, like network issue, like that. So please stay on the line, and we now start. Now we start our today's session. So in up to week 5, we discuss first the different types of foundation, why we use this foundation, what are the different types and how it is defined from deep foundation, how we will define deep foundation and shallow foundation, and then find the bearing capacity problem, solve some problem also, how to find bearing capacity for different type of soil and also for different types of foundation for shallow ones. Then we also go through the in our previous class go through the ground improvement, site ground investigations, how we will site investigation for geotechnical aspect, how we'll go through this site investigation, what are our plans, first plans when we visit in this site, and what we want as a foundation engineer, what we want to know about this soil, what properties we want to know, and how we will find everything we go through. And we also studied the different types of tests which will be helpful for our finding the different engineering properties in the aspect of foundation engineering, like SPT test, CPT test, but it is destructive stress. And uh, also we studied the different type of sampler, undisturbed sampler or disturbed sampler. Undisturbed sampler mostly used for the finding the in situ properties of the soil, like consolidation and permeability, impermeability, like that. And disturb sample we use to disturb sample we use for finding out the specific gravity, port void ratio, like that. Then we also and this SPT and CPT test, that means standard penetration test, and cone penetration depth, it is confined up to a certain depth. We cannot go for larger depth. For this, we use some geophysical investigation, and this geophysical investigation there are two different types of methods, and we today now In today's session, we discuss these types of tests first. After that, we discuss the earth wall, earth retaining wall structure, and different type of earth pressure like active earth pressure, passive earth pressure, and earth pressure at rest, and try to solve some problems. So let's start our session now, and I am sharing the PPTs. This PPT is also available to your Nptel accounts. So I'm same thing. I'm go with the studied. Uh, I same thing I will share to you. So now I share my PPT. Please stay on the line. I think the PPT is visible to everyone. Uh, please wait. I will uh, make some little adjustment. Hello, hello. It is now okay. So, hello, hello. It is okay now. So now I will start our session. So, today's session we discuss the other types of geotechnical investigation software, methods like geophysical seismic reflection method, cross hole method, downhole method, uphole method, and electrical resistivity method. And from this geophysical seismic reflection method and electric resistivity method are most popular. And these tests are non-destructive tests. And by this test, we can find out the properties of soil up to a larger depth like 200-meter below from the ground surface or 500-meter from the ground surface, and we can measures. Then we will discuss the Venn test, which is mostly used for the cohesive soil, soft cohesive soil. So let's start with the geophysical method. So it is said that boring and test pit is the time consuming and expensive and gives subsurface condition only at a boring and a test pit location. So if you boring and test pit method is are nothing but the SPT and CPT test. So it is these tests are time consuming because we have to first bore a hole or dig a test pit, then try to conduct the test. And also it is very expensive because in this test we use expensive uh, a labor or expert or unskilled or skilled labors. So take it is little bit expensive and only give the subsurface condition at at this location only. But say if we dig a bore hole and want to find this ground condition, we only find by SPT or CPT test, we only find at this location only. For other location, we again want to dig another borehole. So this test for this uh, uh, situation, this tests are very expensive. But in by geophysical method like a seismic reflection method, this is very quick and less expensive and can cover a greater area thoroughly. But results are more in qualitative nature. So in geophysical method, we do not need any boring or digging or test pit or borehole. We only need some equipments and try to get create some seismic force one location and find the uh, and observe this seismic waves in another location, and in between this location we want to find the properties in between the soil. Then this geophysical method has different types. In seismic method, there are seismic reflection method, seismic refraction method, seismic up-hole, down-hole, cross-hole method, and then another type is electrical restitutive method. So in seismic reflection method, we if in this method we observe the first arrival of time of P waves. So when there is a disturbance in the ground, the first generated wave is P wave. After that, it is after P wave, it will generate the S wave. So in earthquake also it will happen. So the first arrival time of P wave are recorded through a seismogram. So seismic waves are recorded by seismogram. This is one of the instruments to record the seismic wave. Then then travel time versus travel distance plot are drawn. So from this plot, one can obtain the thickness of the layer and the velocity of waves through each layer, which is related to the shear modulus and elastic modulus of the soil. So by seismic reflection method, we record the first arrival time of POF for a different location by a seismogram. And after that, we plot the time versus travel distance or distance plot. And by this plot, we find out the thickness of the layer and velocity of the wave. And based on these velocities, we find out the shear modulus and elastic modulus by some correlations, because this velocity depends on this layer shear modulus and elastic modulus. So by this way, we can easily find out the properties of soil at a greater depth. So here the arrangement of the seismic reflection method. So we create some disturbance here like this, like explosion, and by this explosion, seismic waves are generated, and we recorded this seismic wave at different location, like here, and observe or try to record the first arrival time of the P waves and plot the distance versus time plot. And in this distance versus time plot, it depends on the shear modulus of the different soil layer and also the velocity of this different layer. So here a formula is given to find out the velocity of each layer. So V1 is the wave velocity of layer 1. So if we divide this ground surface with different layer like layer 1, layer 2, or layer 3. So V1 is the wave velocity of the layer 1, and it is the inverse slope of distance versus time travel time. So here is the time plot, here is the distance plot. So if we drawn the slope in between two lines, then it is the inverse of the velocity is the inverse of the slope. So then V2 is the same thing as velocity, wave velocity, but it is second layer, and it is also the inverse of the slope of the second part of the distance versus time plot. And H1 is the thickness of the top layer. So if we here draw layer 1, layer 2, V1 is the yes layer 1, it is layer 2. V1 is the velocity of the first layer, V2 is the velocity of the second layer, and H is the thickness of the first layer. Then L is the distance taken from the distance versus time plot where two slopes are intersect. So L is nothing but, if we draw here, L is nothing but where is the distance from the origin and the change of the slope. So you can see that the line from here to here is one slope, and which is called line one, and here to here is the slope is different. So the if from the origin, L is the distance from the origin into the uh, point where the slope is changing at the time versus displacement distance curve. So this one is L1. L. So by this formula, so, so first we find out the velocity. So by using this formula, we can find the velocity, which is nothing but the distance, difference of distance L2 minus L1, and difference in time. And after finding the velocity at different layer, we find out the thickness at different layer. Like for first layer thickness, so if we put this formula, or we use this formula, like H1 is equal to half into root over V2 minus V, it is V1, V2 minus V1 by V1 plus V2. The formula is, here is little adjustment. Formula is, I am writing again, H1 is the thickness of the first layer is equal to the half of root over V2 minus V1 divided by V1 plus V2. So by this formula we find out the thickness of the each layer. So here one plot is drawn for different, one test result is given and drawn a plot. If you join like this, first line is here, second line is, so from here to here it is L1, from here to here is L2. So by find out the slope of this line, first find out the slope of this line. Theta 1, theta 2. The inverse of slopes 1 is given the V1, inverse of slope 2 is given V2. After finding the V1, V2, we get find the thickness of the first layer, like half into root over V2 minus V1 divided by V1 plus V2. So like that we solve the problem. Then there is one most popular method is electrical resistivity method. So a soil's resistivity generally varies inversely with its water content and dissolved ion concentration. So resistivity, if you say resistivity is R, or resistance is R, then it is inversely proportional to the water content of the soil and also inversely proportional to the ion concentration. Because if water is more in the soil, then current or current can, so current can easily flow through the soil. Again, if the iron concentration is more, again the what current can easily flow through the soil. So soil resistivity generally varies inversely with its water content and dissolved ion concentration. Because clay soil exhibit the high dissolved ion concentration and wet clay soil have the lowest resistivity of the all soil material, as a low as 1.5 ohm meter. Then coarse dry sand or gravel deposit or massive bedded and hard bedrock have the highest resistivity, like 2400 ohm meter. So clay possess the less resistivity, and sand, coarse gravel, dry sand is possess the highest resistivity because clay has uh, clay has the property to absorb more water and also has the more iron concentration. So the current flow through the clay soil is very good and there is no resistance. So the resistivity of the clay soil is less. Uh, High sensitivities occur in hard bedrock like this. So by evaluating this resistivity properties, we can easily find the what type of soil is there, whether it is clay soil or sandy soil. If the resistivity is less, that means the soil type nature is clay nature. If the resistivity is high, then the nature of the soil is sandy nature, sandy soil. Then resistance to movement of electrical current through the soil is determined by the electric resistivity. So this method is called electrical resistivity method. There is one formula is given to find out the resistivity of the soil, where D is the electrode spacing. That means we, we give or conduct the current through some electrodes in the ground, and the spacing is called D. Then V is the voltage of current, I is the current in amperes, R is the resistance in ohm. So here one table is given for different type of soil. So clay soil, wet to moist, moist nature, the resistance is 1.5 to 3 uh, ohm meter. For silty clay and silty soil, the resistance or resistivity is 3 to 15 ohm meter. For silty sand and sandy soil, the resistivity is 15 to 150 ohm meter. For bedrock, it is 150 to 300 ohm meter. So you see that for clay soil, these values are very less. But if we go to the sandy nature soil, then it is gradually increased. For bedrock, it is highest. Now moving to the lecture number 27. So it is the continuation of the lecture 26. So here now again we see the another type of geotechnical investigation method, which is called venture method, and this method is very popular for the finding out the shear cohesion of the soft saturated clay deposit or very sensitive nature of the soil. So a difficulty often encountered in determining the shear resistance of soft saturated clay deposit is in obtaining the undisturbed sample. The shear strength of such sensitive clays may be significantly altered during the process of sampling and handling. Uh, then Venetian test offer a method of overcoming this problem. So by Venetian method or test, we easily find out the shear resistance, that is cohesion, uh, for this sensitive clay or soft nature of the clay, saturated clay. So one like core beliefs are used to finding out the shear resistance. You want to push into the ground where you want to find the shear resistance and apply the torque. And we measure uh, up to what to how much torque is required to fail the soil, and we record it, and then by using some formulas we find out the shear cohesion of this type of soil. So there is two methods are applied. One is when the you can see that the when we apply these blades into the ground, the shear resistance is occur at this edge of the blade, also this edge, and also at the bottom of the blade and also upside of the blade, upper side of the blade. So if we use the complete four uh, system to finding out the shear resistance, there is one formula. If we only use just this side, and this side, then and we not include upper side, then there is another formula. So we see that here one formula is given, which is torque T is equal to pi Cu, that is cohesion for undrained cohesion into d square h by 2 plus dq by 6. And this formula is for when we use the blade uh, for all sides of the blades, that is this side, this side, this side, and also this side. And this d is nothing but the diameter of this bench here test equipment, and h is the height of the this blade. So if you use all these four sides in our calculation or in our test to find out the shear, then we use this formula, that is torque is equal to pi into undrained cohesion into d square h by 2 plus dq by 6. Then if you use only three sides excluding the upper side, then that means we not including this, we use this three side, then formula is changed, which is nothing but the torque is equal to pi into cu into d square h by 2 plus d cube by 12. So you see that only reference is this d cube for all four sides. Here it is d cube by 6, and for three side it is d cube by 12. So you have to remember this for for this formula. What is the difference when you use all the sides and when you use only three sides excluding the upper side of this blade. Now there is one problem is given based on this Venn formula, and here it is said that we have to find the resistance when, or we find the cohesion when the resistance is given for both from top to bottom, and when the resistance is given only bottom. So you we have to solve this problem. So it is said that the beam diameter is given to 112.5 mm, and is sorry height is given 112.5 mm, and diameter is given 75 mm, and torque is torque torque we have to have torque we have to find, that is T we have to determine when it is said that undrained cohesion is given 40 kilonewton per meter square. So we have to first adjust the unit mm, we have to convert it in meter. So D is equal to 0.075 meter, and H is equal to 0.1125. So after that, for first case, that is we resistance both from top to bottom, then the formula is T is equal to pi Cu d square h by 2 plus d cube by 6. So put all this value here. It is T is 0.075, H is 0.1125, and Cu is 40 kN per meter square. Then it will come in kilonewton meter. After that, you convert it is Newton meter and get the result. So, and for case 2, that is only given resistance only given by bottom only. then this d cube by 6 will be d cube by 12. So I also solve this question here. So you can see that the for resistance from both from top to bottom, then it will be answer will be torque will be 48.6 Newton meter, and there is one change is d cube by 6, and here for bottom resistance this formula is changed is d cube by 12, so it is given 44.2 Newton meter. We have to remember the difference in this formula, in these formulas. Now here it is said that by this method we have to we have to draw some plots or find the correlation between the different engineering properties. Like one is results is given based on the SPT versus vertical stress and for different phi angle. So we have to directly find out if our SPT number is 20 and our angle of resistance or 20 and effective stress is something we call 2, ratio is 2, then our friction angle is in between 35 to 40 degree. So by this plot we can easily find out our different types of engineering properties. These plots are called correlation plots. It is vertical stress and it is converted into atmospheric pressure, ratio of atmospheric pressure. So if our vertical stress, we have to find first calculate the vertical stress at a given depth. Say it is 2, that is this line is 2 vertical stress. And if you say that our number of SPT blow is for a particular soil is 20, if we draw one line here, the intersection point give the for this plot give the angle of internal friction. That means it is almost 36 degrees. So I can say that our phi is 36 degrees for this type of soil. Same type of plot is given for the cone resistance and cone penetration test also. It is CPT. Can find out the phi. Now we move on to the lecture number 28, and in lecture number 28 there is a new topic which is called earth pressure theory. So in earth pressure theory we deal with the pressure generated in the earth retaining structure and what is the safety measures we have to include in our design during the construction of this type of structure. So our pressure theory, we have go through the different types of retaining wall to retain this arch material. So types of the earth retaining structure is divided into two types. One is externally stabilized system, where soil is not a fundamental part, and there is another one which is internally stabilized system, where we include the soil as a fundamental part of the system. So in external stability system, there is gravity wall, a typical small true gravity retaining wall. Then there is crib wall, gabion, and cantilever wall. And there is another type of wall which is called in situ wall, either cantilever or braced or tied back sheet pile wall, shoulder pile. Then earth pressure theories. In earth pressure theories, then there is given figures for different types of retaining wall, which is first one is gravity wall, where we use only the earth or soil or to make this type of wall. Then there is cantilever retaining wall, or gavioning. Then it is called gabion retaining wall. Then this type of retaining wall where we use sheet pile, which is called sheet pile wall. Then crib retaining wall. Then earth pressure theories. Another type is internal stabilized system. So in internal stabilized system, where we use the soil is a fundamental part of the system. So example is earth reinforced soil nailing, where you use the nail to insert into the ground and stabilize the soil. And here soil also is a fundamental part of this system. Then now we come to the different types of earth pressure during this construction of this retaining walls. So why we study this earth pressure first? Actually, for design of foundation wall, that is basement, safe excavation during the construction, and also the design of the earth retaining structure. So we use earth pressure study for this factor, that is for safe designing of the basement of the wall, also safe excavation during the construction, also and also the design of the earth retaining structure. And different types of earth pressure. That one is called earth pressure at rest, another one is active earth pressure, then passive earth pressure. And for different types of earth pressure, there is different coefficient that is earth pressure coefficient, that is for earth pressure at rest, the coefficient is K naught. For earth pressure, active earth pressure, that is Ka. For passive, that is Kp. Now, here one plots is given for based on this earth pressure coefficient. So this earth pressure theories, while movement required to reach the active earth pressure. So here it is said that if we plot the movement versus earth pressure coefficient, if the movement of the wall is towards the backfill, that means what if I draw one wall, retaining wall, one retaining wall like that to cover the to retain the backfill material. Here, here is the retaining wall. This one is retaining wall made of some concrete or gravity material or some other type of gabions walls like that. So backside of this wall, where the soil is rested or taken, it is called backfill material. And this backfill material, the pressure, if this backfill material given the pressure on the retaining wall, it is called active pressure. If the this type of soil at the toe of this retaining wall on the front side of this wall is given pressure, then it is called the passive pressure. And if there is no movement, so due to this soil, here it is the retaining wall. So due to this soil backfill material, the pressure on the backfill material like this, the wall is try to move in this direction. So air from the backfill material, and then this pressure is called active earth pressure. If the due to this, if the soil is or retaining wall is moved from this direction, that is toward the backfill material due to this pressure on this side of our soil, then it is called the passive earth pressure. If there is no movement, then the pressure is called earth pressure at rest. So, in general case, the coefficient of active earth pressure is less than the coefficient of uh, earth pressure is rest, and also earth pressure, passive earth pressure. So if you plot arrange that, the coefficient of active earth pressure is less than the coefficient of earth pressure at rest and less than the coefficient of passive earth pressure. So to generate the active earth pressure, there need some movement of the wall. And it is said that for different types of soil, the movement is different to generate the active to reach the active earth pressure. It said that for dense sand, it requires the movement 0.001 times of h. H is nothing but the height of the retaining wall. So if the soil movement is 0.001 times of h for dense sand, then we can say that here active earth pressure is generated. If towards or move away from the backfill material. For loose sand, it is 0.004 times of h. For stiff clay, it is 0.01 times of h. And for soft clay, from it is 0.02 times of h. But in case of basic earth pressure, it is required the movement towards the backfill material is 0.05 times of h. So in general case, the active earth pressure coefficient is less than all types of coefficient like active earth pressure at rest or passive earth pressure. But the force created by this active earth pressure is larger than the pressure is less, but force created by this active earth pressure is higher than the every case because the area of this backfill material where it is exerted or is higher than the area of this part. So the pressure, we can say force is more in active earth pressure, but the pressure is less. But here it is pressure is more, but force is less. Then there is one table is given for differentiate the active case and passive case. So in active case, wall moves out. Wall moves out means wall move away from the backfill material. So if you draw one wall, this side is passive, front side is passive, and this is the backfill material, and backside which is retained some material, it is called backfill material. If wall move out, that is move away from this backfill material, then it is called active case. If wall moves towards the backfill material, then it is called passive case. Then shear stress on failure plane is reduced. So in active case, the shear stress on failure plane is reduced, but in passive case, the shear stress on uh, failure plane is increased. The lateral pressure reduced in active case, but in lateral pressure is increased in a passive case. Then the minimum lateral stress achieved when soil fails and full strength is mobilized, and maximum lateral stress is achieved when soil fails and full strength is mobilized. So lateral pressure is less in case of active case, and lateral pressure or stress is higher in passive case. Then now one by one we go with these different types of earth pressure case and find out the earth pressure coefficient. So for earth pressure at rest, and we assume that it is for rigid and unyielding wall and frictionless wall. Then we find out the coefficient of earth pressure at rest, which is nothing but the ratio of horizontal uh, earth pressure by the vertical earth pressure. So if you draw one soil particle here, like in a square shape, the pressure which is coming vertically from on this soil particle is nothing but the vertical stress, effective stress, and if we multiply some coefficient on it to find out the horizontal pressure, then it is then this coefficient is called uh, earth pressure at rest when there is no movement of the world. So it is given that this K naught is nothing but the 1 minus sine phi, where sine phi is the angle of internal friction of this type of soil for this type of soil. So it is for earth pressure is rest. This coefficient is 1 minus sine phi. And if you draw this one more circle based on this stress, so if you say that by this formula you can see that it is 1 minus sine phi. So if we know that the value of sine phi is in between 0 to 1, so it is always less than or equal to 1. So we can say that the value of H horizontal pressure is also less than or equal to vertical pressure. So if we draw the Mohr circle, considering these two are principal stress, so sigma H is become minimum principal stress, and sigma V is become major principal stress. So if you draw, minimum side is the left side on the Mohr circle, major sigma V is the major side or right side of the Mohr circle. And we know that at arc features at rest, there is no failure of the retaining wall. So the failure plane cannot cross or intersect the Mohr circle, which is nothing but the phi. So here we draw the Mohr circle based on our soil condition. It is at pressure at rest. Then uh, then we go to the active earth pressure case. So in active earth pressure case, the movement is away from the backfill material. So in case we can draw one figure, we see that at bottom it is applied passive earth pressure, and at top it is applied in the right side it apply active earth pressure, and at the surface of uh, below the surface of the retinol there is one another force which is called sliding friction. But our case we not consider the friction here. So in our case, if we in active pressure case, so in you see that in active pressure case, the coefficient of active earth pressure the is less than one. Then we can see that if we can say that the coefficient of earth pressure is nothing but the ratio of the horizontal stress versus vertical stress. So we know that the coefficient of active earth pressure is less than 1. So we can see that uh, sigma h is less than the sigma v. So if you draw more circle based on this stress, the minor principal stress is sigma h and major principal stress is sigma v. But in our case, the soil is failed due to this active earth pressure. So the failure surface may pass or it has to pass or intersect the surface of the Mohr circle. So we draw like one system where the failure surface must be passed through the surface of the Mohr circle. So if you plot all these uh, points, you can see that for active earth pressure case, the soil failure plane is making an angle with the horizontal is 45 degree plus 5 by 2. So in active earth pressure, the failure plane angle of failure plane is 45 degree 5 by 2, where phi is the nothing but the angle of internal friction of this soil. Then there is passive earth pressure case. So it is the opposite to active earth pressure case, where where uh, wall is moving towards the backfill material. In this case, the passive earth pressure force is more than the active force. So, and also in this case, soil is failed, and the failure surface making angle with horizontal is 45 degree minus 5 by 2, and it also the failure surface should be pass or should be intersect on the surface of the Mohr circle. And if you draw all this force, and in this case, the minimum principal or minor principal stress, sigma v is minor principal stress, and sigma is the minimum, so major principal stress, because Kp, the coefficient of earth pressure coefficient, is greater than always greater than 1. So sigma v is less than sigma h. So plot or draw by this for this problem and find the failure angle of failure surface, which is nothing but 45 degree minus 5 by 2. Now we're moving to lecture 29. So before start with the lecture 29, I think it is better now to take break, 5 minutes break. After that, we will start our session again. So I am now it is time for break. So please don't go away. Stay on the line. So again, we start our session. Hello. Yes. So now we start our session. We already done up to lecture number 28. So now we are on lecture number 29. So in lecture number 29, here we saw that different types of pressure or force act on this retaining wall. So here on the back by this backfill material, the force is called active thrust. For in front of this retaining wall, the force is called uh, passive thrust. Then there is a normal force which is at the bottom of this retaining wall. Then there is a friction force at the bottom of the retaining wall, and there is a self weight of the retaining wall. So these are the force act on the retaining wall while and we have to calculate all this force while designing this retaining wall. So in active earth pressure, in find out the active earth pressure coefficient, there is some assumption we have to make. That is, friction force between backfill and retaining wall are assumed to be negligible. That is, we neglect the friction force, and the wall is straight and the surface of the backfill is horizontal. That means the backfill surface is horizontal and the wall of this retaining wall is straight. Then the backfill material is homogeneous granular soil. That is, this backfill material is only the homogeneous granular soil only, and the failure surface is assumed to be plain. So straight failure surface is assumed. So after that, if you draw again all the force acting on the retaining wall, then we can see that there is only three pressure or three force is only act on the retaining wall. One is the reaction force, another one is active earth pressure thrust, and another one is self weight of the backfill material. So and this failure surface making angle of beta, which is we find that 45 degree plus 5 by 2 for active earth pressure case, and this uh, resultant force are making angle with this failure surface uh, is phi. That is angle between this failure surface and the sitting wall is phi, or failure surface, and the resultant is phi. And by this all this force we making a force triangle, which is nothing but we add find the resultant. We add like this all the forces. We find out the resultant, and this resultant make angle with beta minus phi, where beta is nothing but the 45 degree plus 5 by 2 for active case. Tip case. So with this R is with making this beta minus R with self weight W, self weight of the backfill material, a failure surface, a failure zone. Then by calculation, for solving this fourth triangle, we find out that active application thrust is nothing but half into gamma h square Ka. Thrust is nothing but force. Okay, and this K is nothing but called active earth pressure coefficient, which is equal to L square 45 degree minus pi by 2, or equal to 1 minus sin phi divided by 1 plus sin phi. So we look this derivation very quickly. See that we can write PA is equal to W, which is self weight of this backfill material of this failure zone, into 10 beta minus phi, and after that we find out this self weight, which is nothing but the area of this field material into gamma. So we find that gamma into h, which is nothing but gamma cot beta, h cot beta into h, half into h cos beta into h into gamma. So put all this value in PA. After that, if you differentiate uh, this PA by angle beta for getting the maximum value, we find that beta is equal to 2 beta minus phi is equal to 90 degree, and beta critical is equal to, that is the failure surface angle for critical case is equal to 45 degree plus pi by 2, and put this critical value in this equation and we get that half gamma h square into k. or we can say that half gamma h square into tan square 45 degree minus 5 by 2. And if you replace this tan square 45 minus 5 by 2 with k coefficient and this coefficient called active earth pressure coefficient for active case. Then in similar way, we also find out the passive earth pressure coefficient, and in passive earth pressure coefficient, this angle making the angle between the R and W is beta plus phi. So again, we solve this triangle a similar way. Find that beta is critical angle or beta critical is or critical angle of this failure surface is 45 degree minus 5 by 2, and our Kp is 40 10 square 45 degree plus 5 by 2, which is equal to 1 plus sin phi divided by 1 minus sin phi. So you go through once of this equation derivation. Nothing you have to remember here. Only last formula, that is passive earth pressure thrust and active earth pressure thrust and passive earth pressure thrust we have to remember, that is nothing but half gamma h square into K, and this K we have to remember. So for active case it is, or half gamma Kp. For active case it is 1 minus sin phi by 1 plus sin phi. For passive case it is inverse of K, that is 1 plus sin phi by 1 minus sin phi. Now, now we and this formula are derived only for granular cohesionless granular soil, and this theory is given by Rankine's theory. In Rankine's theory, we not consider the friction of the retaining wall. Now here two more circle is drawn, one for active case, another one for passive case. So left one is for active case, right one is for passive case. So you see that by geometry and trigonometry we can easily find out by more circle this angle of failure surface, critical angle of the failure surface. So critical angle is nothing but when the failure surface is tangential to the Mohr circle. So we have to find out and in our find out this angle with respect to the horizontal uh, arc pressure. So if tangent, if you draw one line which is intersection at a point where its tangent is passed through the small circle, and this angle with respect to horizontal is nothing but the angle of failure angle of this for different arc pressure. So in our case, for active case, the horizontal pressure is in the left side, that is sigma h, and particle pressure is in the right side because k is less than 1. And draw one more circle here. After that, for critical case, the uh, failure surface just tangent to the more circle. So we have to draw one line with respect to the horizontal arc pressure, which is intersects this failure surface at the tangent point. After that, and this failure surface angle is phi always, but with respect to, we have to find this failure surface with respect to uh, horizontal pressure. So we have to find out this angle. So draw one line from the center, which is intersect this tangent point, and this angle is phi, and we know that tangent making an angle of 90 degree with this with the center. So this angle is 90 degree. So this is phi, this is 90 degree. So we can say that this is 90 minus 5. So this angle is 90 plus 5. So after that we have to find out this angle, because this angle and this angle are same. So we know that uh, this is a this side also radius, this side also radius r. So both the sides is same. So angle, this angle also same, this angle also same. So this angle is 90 degree minus 5 by 2, and if you subtract this from 180, this is 180 minus 90 degree minus 5, then it is become 90 plus 5. Total total angle for this is 90 plus 5, and this we know that these two angles are equal, so we divide by 2, and it is become 45 degree plus 5 by 2. So we find out that the surface angle, failure plane angle for active case is 45 degree plus 5 by 2, and which is we calculated with the help of Mohr circle. Similar way, we also calculate this for passive case also to find out the failure surface angle in passive case. So we again draw the Mohr circle. So in passive case, the sigma h is on the right side and sigma p is the left side, because kp is greater than 1. So here it is sigma h, here it is sigma p. Again, one line is drawn which is just tangential to this Mohr circle. Again, one uh, line uh, drawn from the center of the Mohr circle, which is tangent point, intersect the tangent point, and we know that the failure surface is also taken from the horizontal earth pressure, which is intersect the tangent point. So like this, and we find out this angle with respect to horizontal. So we know that again this angle is phi and this angle is 90, because tangent is 90 degree with respect to center. Uh, and so this angle is 90 minus 5. So we say that this is 90 plus 5. Again, this is radius of the circle. This is also radius of the circle. So angle, this angle and this angle is same. So which is nothing but 90 minus 5, subtract from 180 is become 90 plus 5. After that, we divide by 2 because two angles are same, and it is become 45 degree plus 5 by 2. So our failure angle is 45 degree plus 5 by 2. Now you see that for active case it is 45 degree. Uh, sorry, sorry. This is 45 minus 5, and it is 90 minus 5 by 2. Divide by 2, which is become 45 degree minus 5 by 2. For passive case it is 45 degree minus 5 by 2, and active case it is 45 degree plus 5 by 2. So it is active case and it is passive case. So we also find out this active arc pressure thrust based on the Mohr circle. Here it is shown here for active case. If we see that active pressure, to find out the active pressure by using the Mohr circle, we know that when the failure occur, it is uh, tangent to the Mohr circle. So by applying the trigonometry, that is sine phi is nothing but the if it is 90 degree, sine phi is nothing but the this side by this side, and this side is the radius of this Mohr circle, and this side is the distance from the origin to the center. So if you plot, and it is become sigma 1 minus sigma 3 divided by sigma 1 plus sigma 3. After that, if you rearrange uh, this formula, phi is equal to sigma 1 minus sigma 3 by sigma 1 plus sigma 3, and find out uh, sigma 3 from this equation. This formula is looked like in this manner. And case, for active case, this sigma 1 is nothing but the sigma v, and sigma 3 is nothing but the sigma h. So sigma, if you replace sigma 1 with with sigma v, and it will become gamma into h, and which is, if you calculate further, it is become gamma h into tan square 45 degree minus 5 by 2 for active case. And this tan square 45 degree minus 5 by 2 is nothing but the active earth pressure coefficient, this Ka. Then there is, for passive case, similar thing is done, but in passive case, we know that uh, sigma 1 here is nothing but again sigma v. So we arrange this formula, and it is become gamma h tan square 45 degree plus 5 by 2. So move on to lecture number 30. Here it is said that the active earth pressure thrust is equal to gamma h square Ka by 2, and it is act uh, at a distance uh, from the top surface is equal to the 2 by 3 h, because we know that the CG of the triangle is lies at a height uh, 2 by 3 into h from the top, and from the bottom it is 1 by 3. So the pressure, this active earth pressure is create a triangle, active earth pressure triangle, and this is small p, not capital P. So this pressure is act at a distance 2 by 3 from the height, and the force is act 2 by 3 from the height, and h is nothing but the height of the retaining wall. Then if there is one water table present in the in our case, then we know that for Uh, Sorry for the inconvenience. There is a network issue. So we discuss the what is uh, the height, what is the point of action of this active earth pressure thrust from the top, and it is nothing but the 2 by 3 into h. H is nothing but the height of the retaining wall, and it is similar to a triangle. So we use the triangle theory to find out the CG. We know that the CG of the triangle is taken from the top corner is 2 by 3 into h, height of the triangle. From bottom it is 1 by 3 into h. But if the water is present in our case, will then the active earth pressure thrust is adapt adapt with the water. That means we know that in Pascal theory, water exert pressure in all direction. Same pressure is exerted in all direction. So for active earth pressure thrust, it is nothing but the horizontal earth pressure. In horizontal earth pressure, this active earth pressure actually sigma h, or we can say PA, is equal to nothing but the K into sigma V. So to find out the sigma V, we find out the effective vertical stress. But if the water table is present, then there is water pressure also add, because we know that water is exert pressure in all the three directions. So we add the water pressure also to our formula. Then we see that from here to here there is no water table. Our active pressure is at this point is Ka H1 into K H1 into gamma 1, where uh, gamma 1 is the density of this thickness layer of this layer, which thickness is H1, and gamma dash is the unit weight, submerged unit weight of uh, this layer where thickness is H2. So from here to here, there is no water table is present, so there is no add up of extra water pressure. But from here to here, up to this pressure is gamma K into H1 into gamma T. Then there is another pressure will act based due to this submerged wave, and which is K into H2 into gamma submerged, because the water is present here, and we have deduct the water unit weight from this gamma saturated, and it is become gamma submerged. But from here to here, also water exerts some extra pressure horizontal direction. So we add this, which is equal to gamma into H2, where for active earth pressure coefficient for this water is nothing but equal to 1. So, at the bottom point, our total active earth pressure is Ka into H1 into gamma T plus K into gamma dash into H2 plus gamma W into H2. So these are the final formula. To find out the total force, we nothing but we calculate the area of this triangle. So to find out the total active thrust, we find out the area. To find out this area, and to find out this area, and after that we add all this area. Then to find out the CG of this active earth pressure or point of action of For this case, we nothing but do one formula to find out CG, which is equal to, say, this area is A1, this area is A2, this area is A3. Or say, or we can say this is P1, so P1, this is P2, this is P3, and CG of this is Y3, CG of this is from the top is Y2, CG of this is one direction from the top is Y1. So to find out the total point of action, combined point of action, we use this formula P1 Y1 plus P2 Y2 plus P3 Y3 divided by P1 plus P2 plus P3. So by this formula, we have to find out for this case the combined point of action where water also add in the special distribution. Now we discuss the inclined wave field. That means the surface is no longer to horizontal. So it is inclined at an angle of phi. So our active arc pressure coefficient, basis of pressure is modified. So we quickly go to this formula where for active arc pressure coefficient, this formula is look like this, where K is equal to everything is same, so only changes in active arc pressure coefficient and Kc arc pressure coefficient where we include the inclination, ground surface inclination at angle of I, where you can say it is become cos I minus root over cos square I minus cos square phi divided by cos I plus root over cos square I minus cos square phi into cos I. For passive case, it is 1 by active K, so it is become cos I plus root over cos square I minus cos square phi and cos I minus root over cos square I minus cos square phi. So if you put I is equal to 0, it will become 1 minus sin phi, 1 plus sin phi. And if you put I here, there is one term cos I. I is equal to 0, will become 1 plus sin phi by 1 minus sin phi. Then so it is go back to the original formula where inclination is equal to 0. So you have to remember this formula only. Nothing remember for, no need to remember the uh, derivation. Now there is a time to solve previous year assignment problem and also time is running out. So we have to very quick. So I'm quickly move on to the assignment problem. And first we solve the assignment problem 2020. If time permits, also solve the assignment problem 2023. So in 2020, the question asks that in a cross-hole, first question is asked that in a cross-hole test, the trigger and geophone are is 6 meters apart. First question it is, and after impact, the arrival time of shear wave is at geophone is 30 milliseconds. So we have to find out the shear wave velocity. So we know that velocity is equal to distance by time. Here distance is 6 meter and time is 30 milliseconds. That is 30 into 10 to the minus 3 seconds. So if you cut this 2 and this 10 to the power minus 2, then it will become 200 meter per second. So our answer is option A, 200 meter per second. Then in question number 2, it is said that at a depth of 6 meter below the ground surface at a site, a Venetian test gave a torque value of 30 Newton meter. The diameter of vane was 50 millimeter and height was 100 mm. The unleashed shear coefficient we have to find when consider the resistance from both from top and bottom. So we have to use this formula. This top to bottom. This is phi pi, pi into cu and then coefficient into d square h by 2 divided by into plus d cube by 6 because we use both the surface top bottom, and we have to find out the cu. Torque is given 30 newton, d is given 50 mm, that is 0.05 meter, h is given 100 mm, that is zero point 0.1 meter. So put all this value and find the cu, and it will become, I also solve here, it will become 65.51. So closest answer is option C, that is 65 kilonewton per meter square. Then in third question it is said that the inclination of the failure plane behind the vertical wall in active pressure case is inclined to the horizontal at a, we know that for active case the failure plane makes an angle with horizontal is 45 degree plus 5 by 2, and for passive case makes an angle with horizontal is 45 degree minus 5 by 2. So our correct option is option C, that is 45 degree plus 5 by 2. We also prove this by mode circle, also by a post triangle. Then question number 4. In question number 4, it is said that the lateral earth pressure exerted by the soil when the retaining wall moves into the soil. Uh, what type of the pressure it is? So it is said that the lateral earth pressure exerted by the soil when the retaining wall moves into the soil. So we know that for active case, the wall is moved away from the soil, and for passive earth pressure case, the wall is moved into the soil. So correct option is option D, passive earth pressure. And for when the earth pressure at rest, there is no movement of the wall. For active case, it is move away. For passive case, is move into the soil. And then fifth question is this very simple. It is said that rearrange lateral aspect coefficient is given K for active case, Kp for passive case, K naught is at pressure rest, and compare or rearrange according to its value. So we know that the active earth pressure coefficient is less than from every case, then it is less than from K naught. Also, K naught is less than from the Kp. That is passive earth pressure case. So our correct option is option C. That, no, sorry, option B. It is K, not option C. K is less than K naught, less than Kp. Because if you remember, we draw one plot also like this. This is K naught, up to this is K naught, this is K A, and this distance from here to here is Kp. So you see this Ka is less than K naught is less than Kp. So correct option is option B. Then question number 6, they said that as per the Rankine theory, wall friction. So we know that we assume that in while applying the Rankine's theory to find out the active earth pressure coefficient and capacity earth pressure coefficient, the pressure coefficient, we consider or assume that the wall friction is zero for every case. So the correct option is option A, where we consider the wall friction zero in Rankine theory to find out the active earth pressure coefficient. Then question number 7, there is a numerical problem. Said that a retaining wall of height 6 meter retain dry questionless soil. Void ratio and angle of internal friction of this backfill respectively are zero point 0.7 and 30 degree in loose state and zero point 0.3 and 40 degree at dense state. And passive gravity of soil solid is given 2.65. Passive earth pressure as per the Rankine's theory in loose state we have to find if gamma W is given 10 kilonewton per meter cube. So here there is no need for gamma W because there is not present any water table. But it is said that we have to find the passive earth pressure at the passive earth pressure as per the Rankine theory. We have to find the passive earth pressure force. So we know that for passive earth pressure PP is half into gamma H square, right again, half to gamma H square into Kp. Kp is nothing but 1 plus sine phi divided by 1 minus sine phi, or we can say 10 square 45 degree plus phi by 2. So put for loose case our angle is 30 degree, and for and void ratio is E. Sorry, void ratio is zero point 0.7. For loose case, angle is 30 degree and void ratio is zero point 0.7. So there is not given here is gamma is not given. So first find out Kp by putting 5 value, which is 1 minus 1 plus 30 sine 30 degree, 1 divided by 1 minus sine 30 degree. So we know that sine 30 degree is half. Put this value and get the answer, which is equal to 3. To find out the gamma, we consider that this is a dry state, questionless dry state. We use the formula gamma D, which is equal to GS, which is specific gravity of soil solid, into gamma W divided by 1 plus E, which is void ratio. Specific soil solid is given 2.65, gamma W is given 10, and void ratio is given 1 plus zero point 0.7. Put this value and find out the gamma D. After finding this gamma D, all these value put in this formula where h is equal to 6 meter and get the result, which is equal to, we see that gamma D is becomes 15.58, h is 6 meter, void ratio is zero point 0.7, phi is 30 degree, and gs is 2.65. Put all this value here and find out that our active passive earth pressure thrust is equal to 841.32 kilonewton per meter. So correct option is option B. Then question number 8, which is linked to question number 7. In this case, also find out the passive earth pressure coefficient, but in this dense state. So in dense state, it void ratio is zero point 0.3 and phi is 40 degree. So find out gamma which is equal to 2.65, that is G into gamma W, that is 10 divided by 1 plus E is here is zero point 0.3. After that, find out the Kp. Kp is equal to 1 plus sine 40 degree divided by 1 minus sine 40 degree. So it find out this and put again all this value in this equation. So here and also solve here. It is gamma d is become 20.38 and Kp is 4.6. Put all this value, it is become 1687.46. So correct option is option D. Then question number 9. So question number 9 is said that a retaining wall with a smooth vertical back retains sand backfill for a depth of 9 meter. It is height of retaining wall is 9 meter. Backfill as a horizontal surface and has the following properties: C is 0, the equationless soil. Then phi is 30 degree. Gamma is 18 kilonewton per meter cube. Total active thrust, that is PA, we have to find out on a retaining wall as per the Rankine's theory and integrate in the water table effect. So here the formula is half gamma H square into K. K is nothing but the active pressure coefficient. Here it is 1 minus sine phi, 1 plus sine phi. So phi is here 30 degrees. Put this value and get K is equal to 1 by 3. Gamma is given 18, H is given 9. Put all this value and get the answer. And here it is become online solution is become 243 kilonewton per meter. 243 option is correct option, option B. Now, most critical problem is question number 10. It is very critical problem where we need to answer or we deal with the water table. So it is said that the total active thrust have to find out in question number A. So it is become question number 9, not 8. This is question number 9. If said that water table present at 3 meter from the or below the ground surface and there is no drainage also, and if I have to find out the same active earth pressure thrust and gamma d is given for above the water table is 18 kilometer per meter cube and below the water table gamma situated is given 20 kilometer per meter cube. Gamma W is given 10 kilometer per meter cube. So first draw the pressure diagram. So pressure diagram, so it is divided in two layers. One is above the water table is 3 meter, H1 is equal to 3 meter, and below the water level total is 9 meter. So below the water table is become 6 meter. So from the water table present at this distance, from here to here, the passive active earth pressure is uh, at this point is Ka gamma B, that is at the above the uh, gamma is gamma D, at the below the water table gamma is gamma situated. Ka gamma D into H1, and here again, below the water table the pressure at this point is Ka gamma D, because up to this much is same. From here to here the changes occur. have to have same Ka gamma d into H1 up to this. It is become Ka H2 into gamma submerged. That is gamma set minus gamma W plus pressure of water table. From here we consider the water table, so the pressure is at this point is gamma W into H2. So to find out the active thrust, passive thrust, sorry, active thrust for this condition, we need to calculate the area of this triangle, area of this triangle, area of this triangle, and add up. So the area of this triangle is here it is 0 and height is h and base is Ka gamma d into h1 is half h1 into Ka gamma d h1. Area of uh, this part, which is nothing but area of this trapezoidal, which is equal to half of the height h2 into the summation of this base 1 base 2, that is Ka gamma d into h1 plus this one that is again Ka gamma d into h1 plus k Ka gamma submerged into h2, and remaining area is area of water pressure, which is equal to plus half gamma W into H2 into H2. So put all this value here. That is K1, K2, K2, K1, K2, sorry, K, H1, H2, then gamma W and get the result. And it will become 375. I am also solve this question here and also share to everyone. So please try by yourself. So you see that area of this triangle, first one, area of this second one, and area of this third one, and add all this area, and it will become 375 kilonewton per meter. Now we now try the assignment problem of 2023. So because there is a shortage of time, we very quickly go through this assignment problem of 2023. So we see now we move to assignment problem of 2023. So in 2023, question number one is the soil has the lowest resistivity from the following option. We know that uh, the clay soil has the capacity to uh, capture the water content and also has the highest ion concentration. So the current flow through the clay soil is very good. So the resistance of the clay soil for current is very less. So the lowest resistivity is given is for clay soil, or we can say clay soil has the lowest resistivity. So correct option is option A. Second question is given to find out the correct expression for electric resistivity to measure the electrical resistivity of the soil. We know that rho, that is electrical resistivity, is equal to 2 pi d into V by I. So our correct option is option C. Option C. Then question number 3 is asked that for a soil deposit with the angle of internal friction is phi, earth pressure coefficient at rest. So we know that earth pressure coefficient at rest is equal to 1 minus sine phi. So our correct option is option C. Then question number 4, to find out the correct statement about the purpose of the earth pressure study. So why we about the earth pressure study, the first option is given, design the foundation wall, which is correct. Safe excavation during the construction, it is also correct. Then design of earth retaining structure, this is also correct. So the correct option is option D, all of the above. So correct option is all these options are correct. So correct option is all of the above. So option is option D. Then question number 5. In question number 5, said that the correct statement when the wall is in active state. So wall moves out. So this is correct. Shear stress on failure plane increase. If you remember, uh, uh, active versus passive case differentiation, we read one line that shear stress on failure plane is decreased in active case and shear stress on failure plane is increased on passive case. Also, lateral pressure or lateral stress is decreased in active case, lateral stress and lateral pressure is increased in passive case. So only one option is here is correct, that is wall moves out. So our correct option is option A. Then question number 6, it is said that the arrival time of seismic wave is recorded by. So we know that the seismic earthquake or seismic wave recorded by the seismogram. So our correct option is option B. Then question number 7 is asked that a retaining wall with a vertical back retaining a questionless dry backfill at an inclination of beta. So with horizontal. So the backfill surface of the backfill material is inclined surface with an angle of beta. The backfill has an angle of internal friction phi. So soil angle of internal friction is phi. The unit weight gamma and height of wall is given h. Find out the active pressure. So we know that active pressure, earth pressure, thrust is equal to half gamma h square into kp. So for this case, kp is equal to for inclined k, or k is active earth pressure coefficient is equal to for inclined at an angle beta equal to cos beta minus root over cos square beta minus cos square phi divided by cos beta plus root over cos square beta minus cos square phi whole into cos beta. So you put k in this equation and get the result, which is equal to and half gamma a square into cos beta minus root over cos square beta minus sine square cos phi cos uh, square phi divided by cos beta plus root over cos square beta minus cos square phi whole into cos beta. So our correct option is option A. Now move to question number 8. Question number 8 is said a counterfort wall, which is also a retaining wall of 8 meter height on non-cohesive soil backfill. Void ratio and internal friction is given in dense condition 0.35 and 40 degrees respectively. Specific gravity of the soil is given 2.65 and unit of water is given 9.81 kilonewton per meter cube. Then the passive earth pressure on the wall is, so we have to find out the passive earth pressure for this condition. So we know that passive earth pressure coefficient is Kp is equal to 1 plus sine phi divided by 1 minus sine phi. Put the value 40 degree in place of phi and get Kp first. After that, by using this formula again, gamma d is equal to G gamma w divided by 1 plus E. Put this value G is equal to 2.65, T67 gamma w is 9.81, and E is 0.35. After putting all these value, we get the gamma d. Then, using this formula to find out the active, passive thrust, that is equal to half into gamma d into h square. H square is here, h is 8 meter into kp. Put all this value, get the result. Here the answer is 40. Here is the answer is 2855.7 kilonewton per meter. So our correct option is option B. Sorry, option B, 2855. Then question number 9 and 10, combined question. So in question number 9, they said that a retaining wall with a smooth back retains sand backfill at a depth of 5 meter. The backfill has a horizontal surface and the gamma W is given. All these properties are given for this different layer. It is H1, it is H2. So first find out the total active thrust, then it is said that find out the point of action from the surface. So we first draw the pressure diagram for this case in drawing here. So from here to here, then here. So here to here it is Ka gamma into H1. Here it is Ka gamma H1 plus K Ka Ka gamma dash H2, and this is for water gamma W. Same problem we solve in assignment 2020 H2. So after this we divide this area 1, 2, 3 and put and first find area 1, 2, 3 and add up and get the active earth pressure thrust. For finding the point of action from the surface, we first find out the CG distance of each area from the surface. From here to here, I say it is y1. From here to here, it is say y3. From here to here, it is say y2. So for area 1, it is become y1 is equal to 2 by 3 h1. For area 2, y2 is equal to h1 plus 2 by h1 plus 2 by 3 h2. From sorry, h1 plus, it is a trapezoidal. So in trapezoidal it is become, h2 become, let me put this. First, question number 9 is similar to the question number 10 of assignment uh, problem of 2020. So here to here it is, so it is h1 height, this one is h2. So from here to here it is, for area 1 it is h1 by 3, y1 is equal to h1, so 2h1 by 3 y1. From here to here it is y3, which is equal to h1 plus 2 by 3 h2. For this area, that is area 2, the distance from the top, from the CG is equal to, first we find out the CG of this trapezoidal, which is equal to h2 divided by 2b. This is, if you call b2, this is called b1. 2b2 plus b1 divided by b1 plus b2 into 1 by 3 from here, plus this distance h1. So all this, after getting all y1, y2, y3, and then first, then each area p1, p2, p3, put using this formula, we get the total point of action of these forces, which is equal to p1 y1 plus p2 y2 plus p3 y3 divided by p1 plus p2 plus p3, and get the result. So here you see, quickly see the solution. First, find out the active axis charge, that is question number 9. We will find out the force at each triangle, and it is become P1, P2, P3. It will become 56, sorry, 99 kilonewton per meter. And also find the Y1, Y2, Y3, which is equal to, for first area 1.33, for second it is 3.5, and fourth it is 4 meter. Put all this value and get the answer, it is 3.58 meter. If you have any problem, you can ask me regarding this question. You can ask me in the next session also. So I think it is already 6:13. So we now stop here. So for today's, we end our class here. Today's class here. So we will meet again in the next week, which is with number 7. So up to this, we try these problems and try to solve your assignment problems in this year, which is similar to this type of previous year assignment problems only. If you have any difficulty to solving these questions, assignment problems, go through the lectures PPT first and try to solve by yourself. And if you again then any problem, you can ask me in the next class also. And this lectures is recorded, this lecture is recorded, and I will upload in my YouTube channel, and you can access it. And also I am sharing this solution through my Google Drive. Please go through it. So now I am stop here. So good night and best of luck. Thank you.